Hello everyone, today we are here to discuss about the worksheets. We begin with worksheet number 1. The first question that appears on the worksheet is, what is a push or a pull on an object known as? Well, this is a cakewalk. Since we are discussing about the topic called force and pressure, this is what we call as the definition of force. So the option is option number A. I repeat, what is a push or a pull on an object known as? Of course, the answer to this question is force. Coming to question number 2. What is the SI unit of force? Well, the SI unit of force is Newton. You must be aware that any system can be, any physical quantity can be expressed in 3 different ways. The 3 different ways are the MKS system, which is also known as the SI system. We have the CGS system and the FPS system. So in the SI system, that is the MKS system, it is Newton, which is option number B. So what is the answer to this question? The answer to this question is option number B, Newton. The third question is, force has magnitude as well as. A dash is given to in the question. Well, you know what? Force is a vector quantity. Since it's a vector quantity, the direction plays a very important role along with the magnitude. So what should be the answer to this? The answer to this blank is direction. Force has magnitude as well as direction. Coming to the fourth question. Dash is due to interaction. Now, force can act only when it is in when there is an interaction between the bodies. When the interaction is there, then only force comes into play. So the dash over here in question number 4 will be filled up by the word force. So the answer to this is force is due to interaction. Coming to the fifth question. If the two forces applied to an object are equal in magnitude and act in opposite direction, then the net force acting on the object is. Well, let us consider an object which is pulled from either side by a force of 5 Newton. What would happen? The body will not be moving because the net force acting on the body will become 0. So what should be the answer to this question? If the two forces applied on an object are equal in magnitude and act in opposite directions, then the net force acting on the object is 0. So this brings me to the end of worksheet number 1. On to worksheet number 2. Let's see what are the questions given over there. The first question is, give one example where force changes the shape of an object. Well, when we apply force, there are many effects of force that are there. There are in fact 5 effects of force. Of these 5 effects, one is, of course, by the application of force, we can change the shape and size of an object. The 2 examples that comes to my mind is first, when you need a drop. When drop or flow for making chapatis, you use a rolling pin, a balloon, and with that what you actually do is you create a chapati of the flow drop that is there. That is one example. The second example that comes to my mind is that of the potter making a beautiful beautiful shaped vases. Over there what you find, the needed way, the clay which is there, he gives shapes to that. So by the use of force, he can actually give various shapes to the clay that is present with him. The second question that is there, the force applied by a hockey player on a moving ball changes the dash of ball. The options that are given are pull, push, direction and color. A lot of us must have played, or maybe we have watched When a cricket ball or a moving ball is, when a ball is there which is moving, which is hit by a cricket bat or with a hockey stick, what do we find? We find that the direction changes. What changes? The direction. So which option should we take over here? The option given is option number C. So the answer to this question is the force applied by a hockey player on a moving ball changes the direction of the ball. Let's come to the third question. The force applied by a goalkeeper makes the moving ball. The option is to be filled on from the four options that are given to us. The dash rather. The force applied by a goalkeeper makes the moving ball stop, blast, both A and B, neither A nor B. Come on, give me a break. Blast, goalkeeper, no way. So the answer should be stop. So what should be the answer? The force applied by a goalkeeper makes the moving ball stop. Let's come to the fourth question. Force can change the dash of motion of an object. I repeat, force can change the dash of motion of an object. The first thing that clicks, even without looking at the options, I know the answer should be state of motion. Let's still check what are the options given. The options given are size, direction, state, both B and C. No, I would prefer going down with the option number C, which is state of motion, right? Coming to question number 5. When ball is dropped from a height, its speed goes on. When a ball is dropped from a particular height, what would happen? It will be acted upon by a force of gravity. And this force of gravity is also known as the acceleration due to gravity. So what happens when a ball is dropped from a particular height? Its velocity goes on increasing, or the speed goes on increasing. So we can say what? The option number A is the most appropriate one. I repeat this fifth question for you. When ball is dropped from a height, its speed goes on, option number A, increasing. The speed of the ball increases. Discuss the questions that are given on worksheet number 3 now. The first question is, when a plastic comb is rubbed on dry hair, it attracts tiny pieces of paper. Which force is involved in this process? The process that we are actually referring to over here talks about electrostatic force of attraction. When we rub a comb on our hair, on a dry hair, and bring it near small pieces of paper, we would find those pieces of paper gets attracted towards the comb. And why does it happen? Because these uncharged particles gets charged, and in the process they have a electrostatic force of attraction. So what should be the answer to this question? Answer to this question is electrostatic force of attraction. Let's come to question number 2. A small device pulls iron nail from a distance. Well, the device that they are referring to is over here called magnet. I hope you people are aware of this. A small device pulls iron nails from a distance. Which type of force is involved in the process? The process in which a magnet is involved, of course, will be having magnetic force, isn't it? So the options that are given is frictional force, electrostatic force, magnetic force, and gravitational force. Of course, it's magnetic force, which is option number C. Coming to question number 3. A charged body dash an uncharged body towards it. Now, when I am talking about a charged body, what we should do to an uncharged body? Of course, it should be attracting, right? So the option that is given over here, attract, repel, both A and B, neither A or B. Charged body attracts. So that's option number A. A charged body attracts an uncharged body towards itself. Question number 4. Dash force always opposes motion. Now, I'm not going to give you a direct answer for this. You know what? When we are walking on the ground, what do you have? You have a force which tries to pull you back, and this is the force which actually doesn't let you fall down. And which force is that? That force is the frictional force. So among the option that is given to me, electrostatic force, magnetic force, frictional force, and both B and C, I would go down with option number C. So let me complete this statement along with the dash. It says frictional force always opposes motion. Is that okay? Coming to fifth, if we release a magnet held in our hand, well, a very tricky question. If we release a magnet held in our hand, it falls to the ground. The force responsible for this is dash force. Now guys, a few minutes back I said whenever a magnet is involved, we should be having magnetic force. Not in this case. Why? Because here the magnet is just a body, just an object which is released. Since the magnet is released, which force is going to come into play? Because it is getting attracted towards the center of the earth, it comes towards the earth. That's gravitational force. So which option should I go down with? If we release a magnet held in our hand, it falls to the ground. The force responsible for this is option number A, gravitational force. Till now, we have discussed 3 worksheets. All these were dealing with force. This worksheet number 4 will be dealing with pressure. So, let us take the first question. Name the physical quantity whose SI unit is Pascal. There is no prizes for guessing this answer. This is no rocket science. Since this is a topic we are dealing with pressure, so the SI unit of pressure is Pascal. So what is the answer to this question? The answer to this question is pressure. Pressure is the physical quantity whose unit is Pascal. Next question. Why does the shape of a toothpaste tube change when we squeeze it? Well, when we squeeze it, we are actually applying some force. When we are applying force on a particular unit area, it actually counts to be pressure. So what is the physical quantity because of which the shape is changing? The force is the main cause, but it is the pressure which takes out the toothpaste out of the toothpaste tube. Coming down to the third one. The potters use thick round piece of cloth on their heads while carrying heavy loads. Well, you must have gone to the railway stations, and over there you must have found these porters. They are carrying a luggage, heavy luggage on their head, and they put a round cloth. It's a round piece of cloth. You know why do they do that? Because by doing that, they are increasing the surface area of their head. Since they increase the surface area of their head, what would be the effect? The pressure would be less. Now coming down to this question, it says the potters use thick round piece of cloth on their heads while carrying heavy loads to, of course, to decrease the pressure, because if there is more load on your head, that will be detrimental for the potters. So it is decrease pressure, which is option number B. Coming down to question number 4. Why school bags are provided with white straps? The school bags carry books. Now the kids like you, when you carry these books to the school, what happens? It actually has an effect on your shoulder. Now if the straps are thin, the pressure that would be exerted on your shoulders would be more. That's why we actually make the bags of white straps. Since the bags are of white straps, the pressure that is exerted on the shoulders are less, and it becomes easier for the kids to carry the school bags. The last question of this segment is the same force F acts on 4 different objects. Well, the force it mentions is the same as having areas given below 1 by 1. So this force is acting on each of these areas. in which case the pressure exerted will be maximum. Now see, pressure, force and area, they are actually related by the mathematical formula P is equal to F by A, which shows that pressure and area is inversely proportional. So if the pressure needs to be more, the area needs to be less, and vice versa. So over here the areas that are provided to me is 20 meters square, 50 meters square, 10 meters square and 100 meters square, which actually leads me to the conclusion, since the area in case of 10 meters square is the least, that means the pressure that will be exerted will be the maximum in case of case C, which is 10 meters square. Now I'll be discussing the questions that are given on worksheet number 5. So that would be the last set of questions that I'll be discussing. The first question, it says, which type of pressure is involved in filling a liquid in a syringe? Now, what kind of a pressure is that which actually allows the liquid to come into the syringe? It's atmospheric pressure. And what is atmospheric pressure due to? The atmospheric pressure is due to the column of air. The column of air exerts a pressure, and that is known as atmospheric pressure. That actually tries to answer the question, which is question number 2. It says, name the substance whose weight produces the atmospheric pressure. It is the weight of the air column, or simply the air around us. It exerts a pressure on us. The third question is, atmospheric pressure dash with increasing height, and the options are increases, decreases, both A and B, and remains constant. Now, what is atmospheric pressure? This is question number 3 that I'm discussing with you. It says atmospheric pressure, as we go up, as the altitude increases, it decreases, and that is the reason why if people are there who are traveling in vehicle, in the flights, they are advised to wear oxygen masks, or they are advised not to put a fountain pen in their shirt, because that might, the ink might come out and spoil their shirts. Even mountaineers who go down for mountain climbing, they carry oxygen cylinders on their back. So what is it? Atmospheric pressure decreases with increasing height. So what should be my option? Option number B. Come to the next one. The atmospheric pressure is usually measured in a unit of newtons per square meter, meter per square second, kilometer of mercury, and the last one is millimeter of mercury. What do you think the answer should be? Well, the answer is millimeter of mercury. What is it? It is millimeter of mercury. Why do I say millimeter of mercury? In that case, if you refer to the video that I have discussed over there, I've talked about barometric pressure. In barometric pressure, we have a barometer which is filled up with mercury column, and it is calibrated in centimeter. And what happens over there? The value comes down to 76 millimeter of mercury. So that's the answer. The answer is millimeter of mercury. Had it been centimeter of mercury, it could also have been an option, but millimeter of mercury is the option which is available among this. The last question of this worksheet, the worksheet number 5, is a pressure of 10 kilopascal. This is a numerical. A pressure of 10 kilopascal acts on an area of 0.3 meters square. The force acting on the area will be, well, we need to do a little bit of calculation over here. This is a numerical. And what information has been provided to us? The information that has been provided to us is the pressure is given to be 10 kilopascal. Now you are aware that kilo means 10 to the power 3. So what is the pressure? The pressure is 10 into 1000, that is 10,000 pascal. And the area is given to be 0.3 meters square. So what is the formula for pressure? The formula for pressure is P is equal to F by A. Now, if you look around over here, if I make F the subject, I'll be getting F is equal to P into A. Just putting the values of 10,000 and 0.3, what do I get? I'll be getting the answer to be 3,000 Newton. So what should be the answer to this last question of this last worksheet? It is actually 3,000 Newton, which is option number A. So the force acting on the area will be 3,000 Newton. Just for the sake of you, for you people understanding it in a better way, I will be putting a solution on the screen for you.